Hello and welcome to our first code along tutorial on exploratory data analysis using Python. In this tutorial for beginners, we will use data from the UCI database as a data set of features of course. We'll be analyzing this data. I will be using Jupyter Notebook, and you're welcome to use any IDE of your choice. You should also have Python already installed.
Let's get coding. Let's load the packages we're going to use to start with. And these are pandas, matplotlib, seaborn exploit. Next, let's load the data. Let's read that into our data frame. And then output the first 5 rows of our data set. We can see here that we have the miles per gallon, the cylinders, displacement, horsepower, weight, acceleration, model, year, origin, and name. We also want to get the dimensions of the data. And we can see that our data frame has 398 rows and 9 columns. The next thing we want to do is also to get the types of the data types of the features we have in the data sets. And we do that using df.info. And we can see that for float features or float variables, we have MPG, displacement, and acceleration. For integers, we have cylinders, weight, model year, and origin. And for objects, we have horsepower and name. Okay, we can see that the horsepower here are numerical, but for some reason it was given an object type data. For the purposes of this exercise, it's not an object. It is supposed to be numerical, and later on we'll look at how to change the data type of horsepower to a numerical one. Okay. So we can see from this output that we have 398 rows, which was confirmed here from the shape of the data. And none of these features have missing values, as we have the null count, the non-null count summing up to the full number of rows we have in a data set. However, if you still want to check for missing values, you can choose to use this gives you the sum of missing values in the data sets. And as we said earlier, there are no missing values in this data set. All right. So we want to get some description or summary statistics on our data set. So we're going to use df.scribe. And what we see here is that on the MPG, we have the mean miles per gallon being 23.5, the maximum 46.6, the minimum 9, and for cylinders, the lowest number of cylinders on a car in the data set is 3, the maximum is 8, and we can see that less than 75% of the cars, we can see that 75% of the cars in the data set have less than 8 cylinders on their cars. And then for weight, we have the average weight being 2,970 kilograms. The maximum is 5,140. So we can see from the data that 50% of the cars weigh less than 3,000 kilograms on the weight. And then in terms of displacement, we have the mean displacement being approximately 193, and 50% have 148.5 in terms of displacement. So you can see a little bit of skew in the data. The next thing we want to do is to get a description of the non-numerical variables as well. We just include objects. And we can see, as we mentioned earlier, horsepower was wrongly labeled or given the data type object. So that's why it's here and not in the numerical data description. However, for the object data types name, we have 305 unique names in the data set. And of this, Ford Pinto is the most popular brand name among the cars. I did some pre-work and I do know that horsepower has some non-values, so we're going to look at that. Okay. And we can see that there's a question mark in the data set. So there are different ways of handling non-values. You can drop them or you can replace them. Whatever technique you decide, that'll be your prerogative. For this exercise, we're going to use query, so they will not be included in the subsequent data processing we're going to do. So we're going to have data frame objects. We query that. So what are we querying? Horsepower. And what we're saying is we select everything apart from the question mark. After doing that, we change the remaining horsepower values to a numerical data type. Then we check and make sure this was done using df.info. And we can see from the output, the horsepower now has a numerical data type. So this is how we assign or change the object type to a numerical data type for the horsepower. Okay. So the next thing we want to do is to see how our features or variables are correlated using correlation. So what we're going to do is to select the numerical variables There's a correlation on that. And then plots correlation. Okay. So we can see that the dark areas here, for example, here, the dark areas here show a strong correlation. You can see a strong negative correlation. And the lighter ones show a strong positive correlation. Or you want to see the actual values. So we're going to make that not equal to true. And we can see from the output that the miles per gallon has a very strong positive correlation, sorry, it has a strong negative correlation with weight. And not that strong positive correlation with acceleration. So we can call it a weak positive correlation with acceleration. Here, for the value 0.95, we see cylinders and displacement have a very strong positive correlation. Likewise, weight and displacement. Okay. And a strong negative correlation is between weight and acceleration, or a weak negative correlation is between, so a weak negative correlation is between weight and acceleration. Okay. And a strong negative correlation is between MPG and weight. So that's it for the correlation. So next we want to visualize the distribution on our features. Okay, we use a histogram for that. 20 and 12. Number of burns equals 10. And we show so what we have here, we can see a decay for MPG. We can see a decay as the miles per gallon increase. So we have very few cars that are very fuel efficient. We have on cylinders, we have 5 different types of cylinders. Origin, 3 kinds of origin in the data. For the weight as well, we also see a decline. Most of the cars in the data set have a weight between 2,000 and 2,500 kilograms. Very few have weight above 4,500 kilograms. Also want to look at distribution of MPG. We want to compare that with a different number of cylinders on a car. So we're going to use Plotly for that. So we set up our object. I'm going to use histogram. And we are analyzing MPG. And the outputs will be differentiated according to the cylinder on the car. And give our graph a title. Distribution of MPG. We show the graph. For all the cars, we can see that very few are fuel efficient. With the miles per gallon above 40. And these are cars with 4 cylinders. We also see that quite a substantial number of cars are not that fuel efficient or very or low on fuel efficiency, and they have the MPGs between 18 and 20, as well as 14 and 16. So let's remove some of the cylinders. So we analyze cars with 8 cylinders only. For cars with 8 cylinders, we see majority have their miles per gallon between 14 and 16, or we can say between 12 and 16, and very few are fuel efficient with an MPG above 25. If we look at cars with 4 cylinders, majority of them are not that fuel efficient, not not so much. Yeah, and their miles per gallon are between 26 and 28. But we can say majority of the 4 cylinder cars have miles per gallon between 24 and 32, 24 and 32. All right. Very few are fuel efficient with an MPG above 40. Okay. And if we add on cars with 8 cylinders, we can see the difference in the distribution. And this is showing that cars which are more fuel efficient belong to cars with 4 cylinders. All right. Next, let's look at the weight and miles per gallon. Let's see how these two are related. Okay. So we get our object, scatter function, x. We're analyzing weights, x value, x-axis, and the miles per gallon on the y-axis. We are differentiating the outputs by the cylinders. Title. And we show the figure. So in general, we can see a decline and an inverse relationship. As the weight of the car increases, we see the miles per gallon also decrease. And we see 3 clusters, although there's some overlap between the clusters. we can see that the cars that are least fuel efficient are cars with 8 cylinders, and medium fuel efficiency relatively are cars with 6 cylinders, and the relatively cars that are most fuel efficient are those with 4 cylinders. So again, this tells us that the lighter the car, most likely or possibly the more fuel efficient it is. Okay. Then let's do the same for, repeat the same for displacements and miles per gallon. What do we see here? What we can see on the screen is 3 clusters. It's just some overlap. But in general, we see a decline showing that the higher the displacement and I mean a negative correlation indicating that the higher the displacement, the lower the fuel efficiency. Most the cars which have very high displacement are those with 8 cylinders, and relatively medium displacement and medium fuel efficiency are those with 6 cylinders, and the relatively most efficient are those with 4 cylinders. We can see straight lines going upwards within the clusters, indicating that you may have 2 or more cars with similar or the same displacement. However, the miles per gallon are not the same. All right. Finally, let's get to the question. As a buyer with so many cars to choose from, how would you choose the most fuel efficient car? We've seen that displacements and MPG have negative correlation. We've seen that weight and MPG have negative correlation. All right. And we also saw that cars with higher number of cylinders are less fuel efficient. So we can have our own formula. Okay. So let's select the features of interest. So once we know the name of the car, that is fuel efficiency, cylinders, that is placements, the weights, and the miles per gallon. All right. So we want to use from our data cars with the light or relatively lighter weights, let's say less than 3,000 kilograms. Okay. And cars with displacements less than 100. Okay. So when we get that, we want to sort our selection by miles per gallon. We want to do that for the top 5 most fuel efficient cars. So we can see, according to MPG, the one with the most MPG, that is Mazda GLC, it has the highest miles per gallon. Second is Honda Civic, and the third is VW Rabbit, VW pickup, and a VW Dasher. So there you go. This brings us to the end of Code Along session. I hope you enjoyed the session. Thanks for coding along with me. And I hope that you're now familiar with the basics of exploratory data analysis. If you enjoyed this coding session, please like, subscribe, and leave your comments below. See you soon in the next session.